Good morning, dear students. So, today we are studying about the soap. Soaps are detergent used since long and used for the cleaning purpose are sodium or potassium salts of the long chain fatty acids. So, now just like stearic acid, oleic acid, palmic acid, these are the sodiums and potassium salts of long chain fatty acid. For example, is the stearic acid. Second thing, soap containing sodium. Soaps containing sodium salts are formed by heating fat with the aqueous solution of sodium hydroxide, which is known as saponification. So, saponification means soap containing sodium salts. So, in the laboratory, equal volumes of castor oil or vegetable oil, any vegetable oil you can choose, plus concentrated sodium hydroxide solution taken in the beaker, and the paste of the soap is formed by constant stirring during heating. After heating, you can obtain soap plus glycerol. So most of the soap separates out, but some of it remains dissolved in solution. So after some time, NaCl is added. So precipitate out all the soap from aqueous solution. Precipitates, in the short form you can say PPT. Okay, they are coming out from its aqueous solution. So on cooling the solution, solid soap separates out after cooling. So now this is extra information. Now let us see about the equation of them. Here three carbon atoms, 1, 2 and 3 carbon atoms, CH2, CH, CH2, C double O. So here is a C, this side one attached with this carbon, double bond O. Same about C double bond O, C double bond O with 14 carbon atoms and CH3. Total long chain of carbon atom, 15 carbon atoms. 14 plus 1 is a 15 carbon atoms. Plus 3 molecules of NaOH, which gives us this type of the partition OH minus and CH2, they are attached. So CH2OH, CHOH and CH2OH is formed, which is called glycerol. Plus remaining part, all the three sodium atoms attached with this CH3, CH214, COO, Na, and total 3 molecules, which is soap. So a soap is a sodium and potassium salt of a long chain with carboxylic acid, which has cleaning properly in water. Another formula of them is C17H35 and COO Na. COO is a minus and this is plus. So here total 8 mountains. 1, 2, 1 mountain, 2, 3, 4, 5, 6, 7, and 8. This type of every carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, and 17. Okay, here is a 3 hydrogen atoms are attached. Two hydrogens are there. At last, here is a carbon atom attached with double bond O and O minus, COO, and here is a, you can say, Na plus. Okay, this is a sodium stearate soap. Now COO Na, this part is different. This is hydrocarbon part. This hydrocarbon part is a hydrophobic tail. Is called hydrophobic tail. And initial part is hydrophilic head. So the water soluble part, this is water soluble part. This part is ionic. This part, small part, COO Na, is ionic. Is called hydrophilic end. And the insoluble part, water insoluble part, remaining part, this part, which is non-ionic, which is called hydrophobic part. This is a structure of soap. Now let us see about cleaning action of soap. Look here. So when a cloth with a dirt attached to it is immersed in water, is a hydrophobic and combines with the dirt particle. This is here oil droplet is a dirt particle. Then here is all are sodium ions. Na plus. So ionic end points outward and towards the water. So the dirt particles are surrounded by soap molecules are forming structures called, this is called micelle structure. So these micelles get attached with water molecules through the ionic end, which are wasted away along with the dirt particles. Let us see in the language form. So when a cloth with dirt attached to it immersed in water, hydrophobic end combines with dirt particle, and whereas the ionic end points outwards towards the water. Dirt particles are surrounded by the soap molecules forming structure which is called micelles. So these micelles get attached with the water molecules through ionic end and they are wasted away along with the dirt particles. Now soft and hard water. Reaction of soap with the soft water and hard water. So for the soft water easily generates form with the soap, but the hard water contains Okay, but in the hard water, calcium and magnesium, salts of calcium and magnesium, they are present. When the salt of calcium and magnesium reacts with the soap molecules, they form precipitates instead of lather. So, in the hard water, this calcium and magnesium ion replace the sodium ion. Both are replace Na plus ion from fatty acids of salt like this. C17H35 and COONA reacts with CaCl2. Otherwise, you can take MgSO4 also, magnesium sulfate. These are the salts of calcium. This is the salt of magnesium. Okay, calcium ion reacts with sodium. So C17H35 COO twice. Ca is a plus 2. Here is a twice. And Ca plus 2 NaCl is formed. Similarly, here C17H35 COO twice Mg plus 2 NaCl. Okay, so these structures are called scum. SCUM, scum. They are Kurdi precipitates. Is a calcium stearate and this is magnesium stearate. Okay, nomenclature calcium stearate and another is magnesium stearate. Okay, common name for them is scum. So the precipitate form in this reaction is called scum, and since the scum is insoluble in water, and soap cannot form lather in the water. In hard water. So detergents of the sodium salts to long chain of the sulfuric acids which have more cleaning property in water than soap. So detergents are less likely to form scum. So now let us see about detergent.